We're at the very, very early stage of the intelligence Big Bang. Being a multi-planet species greatly increases the probable lifespan of civilization or consciousness or intelligence, both biological and digital. I think we're quite close to digital superintelligence. If it doesn't happen this year, next year for sure.
Please give it up for Elon Musk. Elon, welcome to AI Startup School. We're just really blessed to have your presence here today.
Thanks for having me.
So, from SpaceX, Tesla, Neuralink, XAI, and more, was there ever a moment in your life before all this where you felt, I have to build something great? And what flipped that switch for you?
Well, I didn't originally think I would build something great. I wanted to try to build something useful, but I didn't think I would build anything particularly great. If you said probabilistically, it seemed unlikely, but I wanted to at least try.
So you're talking to a room full of people who are all technical engineers, often some of the most eminent AI researchers coming up in the game.
Okay.
I,
I think we should. I like the term engineer better than researcher. I mean, I suppose if there's some fundamental algorithmic breakthrough, it's research, but otherwise it's engineering.
Maybe let's start way back. I mean, when you were, this is a room full of 18 to 25-year-olds. It skews younger because the founder set is younger and younger. Can you put yourself back into their shoes when, you were 18, 19, learning to code, even coming up with a first idea for Zip2? What was that like for you?
Yeah, back in '95, I was faced with a choice of either do grad studies, PhD at Stanford, in material science, actually working on ultracapacitors for potential use in electric vehicles, essentially trying to solve the range problem for electric vehicles, or try to do something in this thing that most people had never heard of called the internet. And I talked to my professor, who was Bill Nix, in the material science department, and said, like, can I defer for the quarter because this will probably fail, and then I'll need to come back to college. And then he said, this is probably the last conversation we'll have, and he was right. But I thought things would most likely fail, not that they would most likely succeed. And then in '95, I wrote basically, I think the first or close to the first maps, directions, internet, white pages and yellow pages on the internet. I just wrote that personally, and I didn't even use a web server. I just read the port directly because I couldn't afford, and I couldn't afford a T1. The original office was on Sherman Avenue in Palo Alto. There was like an ISP on the floor below, so I drilled a hole through the floor and just ran a LAN cable directly to the ISP. My brother joined me and another co-founder, Greg Curry, who passed away, and we at the time we couldn't even afford a place to stay, so we just the office was $500 a month, so we just slept in the office and then showered at the YMCA on Page Mill in El Camino. And I guess we ended up doing a little bit of a useful company, Zip2 in the beginning. We did build a lot of really good software technology, but we're somewhat captured by the legacy media companies, and that Knight Ridder, New York Times, and the Hearst, whatnot, were investors and customers, and also on the board. So they kept wanting to use our software in ways that made no sense. So I wanted to go direct to consumers. Anyway, it's a long story, dwelling too much on Zip2, but I really just wanted to do something useful on the internet. Because I had like two choices, like do a PhD and watch people build the internet, or help build the internet in some small way. And I was like, well, I guess I can always try and fail and then go back to grad studies. Um, and anyway, that ended up being like reasonably successful. It sold for like $300 million, which was a lot at the time. These days, that's like, I think minimum impulse bid for an AI startup is like $1 billion. It's like there's so many friggin' unicorns. It's like a herd of unicorns at this point. You know, if unicorn's $1 billion situation.
There's been inflation since, so quite a
Yeah,
bit
there has
more
been
money
inflation.
actually.
Yeah, I mean, like 9.95, you could probably buy a burger for a nickel. Well, not quite, but I mean, yeah, there has been a lot of inflation. Um, but I mean, the hype level on AI is pretty intense, as you've seen. You know, you see companies that are, I don't know, less than a year old getting sometimes billion-dollar or multi-billion-dollar valuations, um, which I guess could pan out and probably will pan out in some cases. But it is eye-watering to see some of these valuations. Um, yeah, what do you think?
I mean, well, I'm pretty bullish personally.
Yeah, what can you
I'm
say
pretty
about that?
bullish, honestly. So I think the
Sure,
people in this room are going to create a lot of the value that, you know, a billion people in the world should be using this stuff, and
sure.
we're not even we're scratching the surface of it. I love the internet story in that even back then, you know, you are a lot like the people in this room back then, in that, you know, the heads of all the CEOs of all the legacy media companies look to you
Yeah,
as the person who understood the internet. And a lot of the world, the you know, the corporate world, like the world at large that does not understand what's happening with AI, they're going to look to the people in this room for exactly that. It sounds like, well, you know, what are some of the tangible lessons? It sounds like one of them is don't give up board control, or be careful about, have a
well,
really good lawyer.
uh, I guess with my first startup, the big the really the mistake was having too much shareholder and board control from legacy media companies, who then necessarily see things through the lens of legacy media, and that they'll kind of make you do things that seem sensible to them, but aren't really don't make sense with the new technology. I know I should point out that I didn't actually at first intend to start a company. I tried to get a job at Netscape. I sent my resume into Netscape, and Mark Andreessen knows about this. And but I don't think he ever saw my resume, and then nobody responded. So and then I tried hanging out in the lobby of Netscape to see if I could like bump into someone, but I was like too shy to talk to anyone. So I'm like, man, this is ridiculous. So I'll just write software myself and see how it goes. So it wasn't actually from the standpoint of like I want to start a company. I just want to be part of building, you know, the internet in some way. And since I couldn't get a job at an internet company, I had to start a internet company. Anyway, yeah, I mean, from an AI will so profoundly change the future. It's difficult to fathom how much, but you know, the economy, assuming we don't things don't go awry, and like AI doesn't kill us or will end itself, um, then you'll see ultimately an economy that is not 10 times more than the current economy. Ultimately, like if we become, say, or whatever our future machine descendants, or but mostly machine descendants become like a Kardashev scale 2 civilization or beyond, we're talking about an economy that is thousands of times, maybe millions of times bigger than the economy today. So yeah, I mean, I did sort of feel a bit like, you know, when I was in DC taking a lot of flack for like getting rid of waste and fraud, which was an interesting side quest, as side quests go. Um, but as
Got to get
learning,
back to the
you know,
main quest.
yeah, I got to get back to the main quest here. So back to the main quest. But I did feel, you know, a little bit like there's, you know, it's like fixing the government is kind of like there's like, say, the beach is dirty and there's like some needles and feces and like trash and you want to clean up the beach. But then there's also this like 1,000-foot wall of water, which is a tsunami of AI. Like, and how much does cleaning the beach really matter if you got a 1,000-foot tsunami about to hit? Not that much.
Oh,
So
we're
that's
glad you're
AI.
back on the main quest. It's very important.
Yeah, back to the main quest. Building technology, which is what I like doing.
Yeah.
Um, it's just so much noise. Like this, the signal to noise ratio in politics is terrible. So um,
I mean, I live
there,
in San Francisco, so you don't need to tell me twice.
yeah, DC is like kind of. I guess it's all politics in DC, but um, the if you're trying to build a rocket or cars, or you're trying to have software that compiles and runs reliably, then you have to be maximally truth-seeking, or your software or your hardware won't work. Um, like there's no, you can't fool math. Like math and physics are rigorous judges. So I'm used to being in like a maximally truth-seeking environment, and that's definitely not politics. Um, so anyway, I'm glad to be back in technology.
I guess I'm kind of curious, going back to the Zip2 moment, you had hundreds of millions of dollars, or you had an exit of worth hundreds of millions of
Yeah, I mean,
dollars.
I got $20 million
Right.
before
Okay, so
tax.
you solved the money problem at least. Um, and you basically took it and you kept rolling with X.com, which
Yeah.
became PayPal and Confinity.
Yes. I kept the chips on the table.
Yeah.
So
Not everyone does that. A lot of the people in this room will have to
yeah.
make that decision, actually. What drove you to jump back into the ring?
Well, I think I felt for with Zip2, we built like incredible technology, but it never really got used. Um, I think at least from my perspective, we had better technology than say Yahoo or anyone else, but it was constrained by our customers. Um, And so I wanted to do something that where, okay, we wouldn't be constrained by our customers, go direct to consumer. And that's what ended up being like X.com, PayPal, essentially X.com merging with Confinity, which together created PayPal. And then that actually, the sort of PayPal diaspora has, it might have created more companies than, so there's more companies than probably anything in the 21st century, so many talented people were at the combination of Confinity and X.com. um so I just wanted to, like, I felt like we kind of got our wings clipped somewhat with Zip2, and it's like, okay, what if our wings aren't clipped and we go direct to consumer? And that's what PayPal ended up being. But yeah, with I got that like $20 million check for my share of Zip2. At the time, I was living in a house with four housemates, um, and had like, I don't know, 10 grand in the bank. And then the this check arrives in the mail, of all places, and it's in the mail. Then my bank balance went from 10,000 to 20 million and 10,000. You're like, well, okay. Still have to pay taxes on that and all, but then I ended up putting almost all of that into X.com, and as you said, like, just kind of keeping almost all the chips on the table. Um, and Yeah, and then after PayPal, I was like, well, I was kind of curious as to why we had not sent anyone to Mars. And I went on the NASA website to find out when we're sending people to Mars, and there was no date. I thought maybe it was just hard to find on the website, but in fact, there was no real plan to send people to Mars. So then, this is such a long story, so I don't want to take up too much time here. But
I
the
think we're all listening with rapt attention.
so I was actually I was on the Long Island Expressway with my friend Deo Resi. We were like housemates in college, and Dale was asking me what we're gonna do, what am I gonna do after PayPal, and I was like, it's like, I don't know, I guess maybe I'd like to do something philanthropic in space, because I didn't think I could actually do anything commercial in space, because that seemed like the purview of nations. So, um, but I'm kind of curious as to when we're gonna send people to Mars, and that's when I was like, oh, it's not on the website, and then I started digging on, not there's nothing on the NASA website, so then I started digging in, and uh, and I'm definitely summarizing a lot here, but um, I I my first idea was to do a philanthropic mission to Mars called Life to Mars, where it would send a small greenhouse with seeds and dehydrated nutrient gel, land that on Mars and grow, hydrate the gel, and then you'd have this great sort of money shot of green plants on a red background. Um, for the longest time, by the way, I didn't realize money shot, I think, is a porn reference, uh, but anyway, the point is that that would be the great shot of green plants on a red background, and to try to inspire, NASA and the public to send astronauts to Mars. As I learned more, I came to realize. Oh, and along the way, by the way, I went to Russia in like 2001 and 2002 to buy ICBMs, which is like, that's an adventure. You go and meet with Russian high command and say, I'd like to buy some ICBMs.
This was to get to space
Yeah,
as a
yeah, yeah.
rocket.
Not to nuke anyone, uh, but they had to, as a result of arms reduction talks, they had to actually destroy a bunch of their big nuclear missiles. So I was like, well, how about if we take two of those, minus the nuke, add an additional upper stage for Mars. But it was kind of trippy, being in Moscow in 2001, negotiating with like the Russian military to buy ICBMs. Like, that's crazy. um, and but they kept also like raising the price on me, so like literally it's kind of like the opposite of what a negotiation should do. So I was like, man, these things are getting really expensive. And then I came to realize that actually the problem was not that there was insufficient will to go to Mars, but there was no way to do so without breaking the budget, even breaking the NASA budget. So that's where I decided to start SpaceX to advance rocket technology to the point where we could send people to Mars. Um, and that was in 2002.
So that wasn't, you didn't start out wanting to start a business. You wanted to start just something that was interesting to you, that you thought humanity needed. And then as you sort of, like a
Yeah,
cat pulling on, a string, it just sort of, the ball sort of unravels, and it turns out this
yeah.
could be a very profitable business.
I mean, it is now, but um, there there've been no prior example of really a rocket startup succeeding. There've been various attempts to do commercial rocket companies, and they all failed. So again, with SpaceX, starting SpaceX was really from the standpoint of like, I think there's like a less than 10% chance of being successful, maybe 1%, I don't know. But if a startup doesn't do something to advance rocket technology, it's definitely not coming from the big defense contractors, because they just impedance match to the government, and the government just wants to do very conventional things. So it's either coming from a startup or it's not happening at all. So like a small chance of success is better than no chance of success. And so SpaceX, uh, I started that in mid 2002, expecting to fail. Like I said, probably 90% chance of failing. And even like when recruiting people, I didn't like try to, make out that it would. I said we're probably going to die, but small chance we might not die. And but this is the only way to get people to Mars and advance the state of the art. And then I ended up being chief engineer of the rocket, not because I wanted to, but because I couldn't hire anyone who was good. So like none of the good sort of chief engineers would join, because it was like, this is too risky, you're going to die. And so then I ended up being chief engineer of the rocket. And the first three flights did fail, so it's a bit of a learning exercise there. And fourth one fortunately worked, but if the fourth one hadn't worked, I had no money left, and it would have been curtains. So it was a pretty close thing. If the fourth launch of Falcon not work, it would have been just curtains, and we would have just joined the graveyard of prior rocket startups. So like my estimate of success was not far off. We made it by the skin of our teeth. And Tesla was happening sort of simultaneously. Like 2008 was a rough year, because at mid 2008, or called summer 2008, the third the third launch of SpaceX had failed, a third failure in a row. The Tesla financing round had failed, and so Tesla was going bankrupt fast. Um, it was just it's like, man, this is grim. This is going to be a tale of warning of an exercise in hubris.
Probably throughout that period, a lot of people were saying, Elon is a software guy. Why
Oh
is he
yeah, no,
working
like
on hardware? Why would,
you
yeah, why
tell
would he choose to work on this, right?
100%. So you can look at the like the because there's still the press of that time is still online. You can just search it, and they kept calling me internet guy. Um, so like internet guy, aka fool, is attempting to build a rocket company. Um, so you know, that we got ridiculed quite a lot. Um, and it does sound pretty absurd. Like internet guy starts rocket company doesn't sound like a recipe for success, frankly. So I didn't hold it against them. I was like, yeah, admittedly, it does sound improbable, and I agree that it's improbable. Um, but fortunately, the fourth launch worked, and NASA awarded us a contract to resupply the space station. And I think that was like maybe, I don't know, December 22nd, or it was like right before Christmas. Because even the fourth launch working wasn't enough to succeed. NASA also we also needed a big contract to keep us alive. Um, so I got that call from like the NASA team, and I literally they said, we're awarding you one of the contracts to resupply the space station. And I like literally blurted out, "I love you guys," which is not normally what they hear, because it's usually pretty you know sober. But I was like, man, this is a company saver. And then we closed the Tesla financing round on the last hour of the last day that it was possible, which was 6 p.m. December 24th, 2008. We would have bounced payroll 2 days after Christmas if that round hadn't closed. So that was a
Okay.
nerve-wracking end of 2008, that's for sure.
I guess
Um,
from your PayPal and Zip2 experience, jumping into these hardcore hardware startups, it feels like one of the through lines was being able to find and eventually attract the smartest possible people in those particular fields. You know,
yeah,
I mean, the people in this room, like most of the people here, I don't think have even managed a single person yet. They're just starting their careers. What would you tell to, the Elon who's never had to do that yet?
I generally think to try to be as useful as possible. It may sound trite, but it's so hard to be useful, especially to be useful to a lot of people. Uh, where you say the area under the curve of total utility is like how useful have you been to your fellow human beings times how many people. Um, it's almost like the physics definition of true work. It's incredibly difficult to do that. And I think if you aspire to do true work, your probability of success is much higher. Um, like don't aspire to glory, aspire to work.
How can you tell that it's true work? Like, is it external? Is it like what happens with other people, or what the product does for people? Like, what is that for you when you're looking for people to
Yeah,
come work for you? Like,
like
what's the salient thing that you look for, or if there are,
well,
a
that's a
few?
different question, I guess. I mean, if, in terms of, of your end product, you just have to say like, well, if this thing is successful, how useful will it be to how many people? And that's what I mean. And then you do whatever, whether you're CEO or any role in a startup, you do whatever it takes to succeed. Like and just always be smashing your ego. Like internalize responsibility. Um, like a major failure mode is when ego to ability ratio um, is double greater than sine one. You know, like if your ego to ability ratio it gets too high, then you're going to basically break the feedback loop to reality. And in AI terms, your RL you'll break your RL loop. So you don't want to break you want to have a strong RL loop, which means internalizing responsibility and minimizing ego, and you do whatever the task is, no matter whether it's grand or humble. So I mean that's kind of like why I prefer the term like engineering as opposed to research. I prefer the term, and I actually don't want it to call XAI a lab. I just want it to be a company. Um, it's like whatever the simplest, um, most straightforward, uh, ideally lowest ego terms are. Those are generally a good way to go.
Yeah.
Um, You want to just close the loop on reality hard. Um, that's a super big deal.
I think everyone in this room is really looks up to everything you've done around being sort of a paragon of first principles, and thinking about the
Yes.
stuff you've done. Um, how do you actually determine your reality? Because that seems like a pretty big part of it. Like other people who have never made anything, non-engineers, sometimes journalists at time who've never done anything, like they will criticize you. But then clearly you have another set of people who are builders, who have very high, sort of area under the curve, who are in your circle. Like, how should people approach that? Like, what has worked for you, and what would you pass on, like, to X, to your children? Like, what do you tell them when you're like, you need to make your way in this world? Here, here's how to construct a reality that is predictive from first principles.
Well, the tools of physics are incredibly helpful to understand and make progress in any field. And first principles means just means break things down to the fundamental axiomatic elements that are most likely to be true, and then reason up from there as cogently as possible, as opposed to reasoning by analysis or metaphor. Um, and then it just simple things like thinking in the limit. Like if you extrapolate, you know, minimize this thing or maximize that thing, thinking in the limit is very helpful. I'd use all the tools of physics. Um, they apply to any field. Um, this is like a superpower, actually. Um, so you can take for example like rockets. You could say, well, how much should a rocket cost? Um, the typical approach to how to that people would take to how much rocket should cost is they would look historically at what the cost of rockets are and assume that any new rocket must be somewhat similar to the prior cost of rockets. A first principles approach would be you look at the materials that the rocket is comprised of. So if that's aluminum, copper, carbon fiber, steel, whatever the case may be, and say what how much does that rocket weigh, and what are the constituent elements, and how much do they weigh? What is the material price per kilogram of those constituent elements? And that sets the actual floor on what a rocket can cost. It can asymptotically approach the cost of the raw materials. And then you realize, oh, actually, the raw materials of a rocket are only maybe 1 or 2% of the historical cost of a rocket. So the manufacturing must necessarily be very inefficient um, if the raw material cost is only 1 or 2%. That would be a first principles analysis of the potential for for cost optimization of a rocket, and that's before you get to reusability. To give an AI sort of AI example, I guess last year for XAI, when we were trying to build a, a training supercluster, we went to the various suppliers to ask. They said this was beginning of last year that we needed 100,000 H100s to be able to train coherently, and their estimates for how long it would take to complete that were 18 to 24 months. It's like, well, we need to get that done in 6 months. So then, or we won't be competitive. So then, if you break that down, what are the things you need? Well, you need a building, you need power, you need cooling. We didn't have enough time to build a building from scratch, so we've had to find an existing building. So we found a factory that was no longer in use in Memphis that used to build Electrolux products. But then the input power was 15 megawatts, and we needed 150 megawatts. So we rented generators and had generators on one side of the building, and then we have to have cooling. So we rented about a quarter of the mobile cooling capacity of the U.S. and put the chillers on the other side of the building. That didn't fully solve the problem because the the power variations during training are very big. So you can have power can drop by 50% in 100 milliseconds, which the generators can't keep up with. So then we added Tesla Megapacks and modified the software in the Megapacks to be able to smooth out the power variation during the training run. And then there were a bunch of networking challenges because the networking cables, if you're trying to make 100,000 GPUs train coherently, are very challenging.
Almost, it sounds like
So
almost any of those things you mentioned, I could imagine someone telling you very directly, no, you can't have that, you can't have that power, you can't have this. And it sounds like one of the salient pieces of first principles thinking is actually, let's ask why. Let's, figure that out, and actually let's
Yeah.
challenge the person across the table. And if I don't get an answer that I feel good about, I'm gonna, not allow that to be. I'm not gonna let that no to stand. Is that? I mean, that feels like something that, everyone. If someone were to try to do what you're doing in hardware seems to uniquely need this. In software, we have lots of, fluff and things that, it's like we can add more CPUs for that, it'll be fine. But in hardware, it's just not going to work.
I think these general principles of first principle thinking apply to software and hardware, apply to anything really. I'm just using kind of a hardware example um, of how we were told something is impossible, but once we broke it down into the constituent elements of we need a building, we need power, we need cooling, we need power smoothing, and then we could solve those constituent elements. But it was, and then we just ran the networking operation to do all the cabling, everything, in 4 shifts, 24/7, and I was like sleeping in the data center and also doing cabling myself. And there were a lot of other issues to solve. Nobody had done a training run with 100,000 H100s training coherently last year. I mean, maybe it's been done this year, I don't know, but and then we ended up doubling that to 200,000, and so now we've got 150,000 H100s, 50K H200s, and 30K GB200s in the Memphis training center, and we're about to bring 110,000 GB200s online at a second data center, also in the Memphis area.
Is it your view that, pre-training still working, and the scaling laws still hold, and whoever wins this race will have basically the biggest, smartest possible model that you could distill?
Well, there's other various elements that beside competitiveness for large AI. There's for sure the talent of the people matter. The scale of the hardware matters, and how well you're able to bring that hardware to bear. So you can't just order a whole bunch of GPUs and they don't. Then you can't just plug them in. So you've got to get a lot of GPUs and have them train coherently and stably. Then it's like, what unique access to data do you have? I guess distribution matters to some degree as well. Like, how do people get exposed to your AI? Those are critical factors for if it's going to be like a large foundation model that's competitive. Um, as many have said, I think my friend Elias Sutskeyer has said, we've kind of run out of pre-training data of human-generated human-generated data. You run out of tokens pretty fast. Certainly of high quality tokens, and then you have to do a lot of you need to essentially create synthetic data, and be able to accurately judge the synthetic data that you're creating to verify, like, is this real synthetic data, or is it an hallucination that doesn't actually match reality? So achieving grounding in reality is tricky, but we are at the stage where there's more effort put into synthetic data, and like right now we're training Grok 3.5, which is a heavy focus on reasoning.
Going back to your physics point, what I heard for reasoning is
Yeah.
that hard science, particularly physics textbooks, are very useful for reasoning, whereas I think researchers have told me that social science is totally useless for reasoning.
Yes, that's probably true. So yeah, there's something that's going to be very important in the future is combining deep AI in the data center or supercluster with robotics. So that things like the Optimus humanoid robot,
Incredible.
and yeah, Optimus is awesome. There's going to be so many humanoid robots and robots of all sizes and shapes. But my prediction is that there will be more humanoid robots by far than all other robots combined, by maybe an order of magnitude, like a big difference. And
Is it
it
true
turns
that
out
you're planning a robot army of a sort?
whether we do it or whether Tesla does it, Tesla works closely with XAI. Um, like you've seen how many humanoid robot startups are there. Like it's like I think Jensen Huang was on stage with a massive number of robots, you know, robots from different companies. I think there was like a dozen different humanoid robots. So, I mean, I guess part of what I've been fighting and maybe what has slowed me down somewhat is that I'm a little I don't want to make Terminator real, you know. So I've been sort of, I guess, at least until recent years, dragging my feet on AI and humanoid robotics. And then I sort of come to the realization it's happening whether I do it or not. So you got really two choices. You could either be a spectator or a participant. And so like, well, I guess I'd rather be a participant than a spectator. So now it's, pedal to the metal on humanoid robots and digital superintelligence.
So I guess there's a third thing that everyone has heard you talk a lot about that I'm really a big fan of. Becoming a multiplanetary species. Where does this fit? This is all not just a 10 or 20 year thing, maybe 100 year thing. Like it's a many generations for humanity kind of thing. You know, how do you think about it? There's AI, obviously. There's embodied robotics, and then there's being a multiplanetary species. Does everything sort of feed into that last point, or what are you driven by right now for the next 10, 20, and 100 years?
Geez, 100 years, man. I hope civilization's around in 100 years. If it is around, it's going to look very different from civilization today. Um, I mean, I'd predict that there's going to be at least 5 times as many humanoid robots as there are humans, maybe 10 times. Um, and one way to look at the progress of civilization is percentage completion Kardashev. So if you're, Kardashev scale 1, um, you've harnessed all the energy of a planet. Now, in my opinion, we've only harnessed maybe 1 or 2% of Earth's energy. So we've got a long way to go to be Kardashev scale 1. Then Kardashev 2, you've harnessed all the energy of a sun, which would be, I don't know, 1 billion times more energy than Earth, maybe closer to 1 trillion. And then Kardashev 3 would be all the energy of a galaxy. Pretty far from that. So we're at the very, very early stage of the intelligence Big Bang. I hope we're on in terms of being multiplanetary. Like I think we'll have enough mass transferred to Mars within like roughly 30 years to make Mars self-sustaining, such that Mars can continue to grow and prosper even if the resupply ships from Earth stop coming. And that greatly increases the probable lifespan of civilization or consciousness or intelligence, both biological and digital. So that's why I think it's important to become a multi-planet species. And I'm somewhat troubled by the Fermi paradox. Like, why have we not seen any aliens? And it could be because intelligence is incredibly rare. And maybe we're the only ones in this galaxy, in which case the intelligence of consciousness is this like tiny candle in a vast darkness. And we should do everything possible to ensure the tiny candle does not go out. And being a multi-planet species, or making consciousness multiplanetary, greatly improves the probable lifespan of civilization. And it's the next step before going to other star systems. Once you at least have 2 planets, then you've got a forcing function for the improvement of space travel, and that ultimately is what will lead to consciousness expanding to the stars.
It could be that the Fermi paradox dictates once you get to some level of technology, you destroy yourself. How do we
Yeah,
stay ourselves? How do we actually, what would you prescribe to, I mean, a room full of engineers? Like, what can we do to prevent that from happening?
yeah. How do we avoid the great filters? One of the great filters would obviously be global thermonuclear war. Uh, so we should try to avoid that. Um, I guess building benign AI robots that AI that loves humanity, and um, robots that are helpful. Something that I think is extremely important in building AI is a very rigorous adherence to truth, even if that truth is politically incorrect. My intuition for what could make AI very dangerous is if you force AI to believe things that are not true.
How do you think about, there's sort of this argument for open for safety versus closed for competitive edge. I mean, I think the great thing is you have a competitive model. Many other people also have competitive models. And in that sense, we're sort of off of maybe the worst timeline that I'd be worried about is, there's fast takeoff and it's only in one person's hands. That might, sort of collapse a lot of things. Whereas now we have choice, which is great. How do you think about
Yeah,
this?
I do think there will be several deep intelligences, maybe at least five, um, maybe as much as 10. Um, I'm not sure that there's going to be hundreds, but it's probably close to, like, maybe there'll be like 10 or something like that, of which maybe 4 will be in the US. Um, so I don't think it's going to be any one AI that has a runaway capability. Um, but yeah, several deep intelligences.
What will these deep intelligences actually be doing? Will it be scientific research or trying to hack each other?
Probably all of the above.
Mm.
Um, I mean, hopefully they will discover new physics, and I think they will very they're definitely going to invent new technologies. Um, like I think we're quite close to digital superintelligence. It may happen this year, and if it doesn't happen this year, next year for sure. A digital superintelligence defined as smarter than any human at anything.
Well, so how do we direct that to sort of superabundance? We could have robotic labor, we have cheap energy, intelligence on demand. Is that sort of the white pill? Like, where do you sit on the spectrum? And are there tangible things that you would encourage everyone here to be working on to make that white pill actually reality?
I think it most likely will be a good outcome. I guess I'd sort of agree with Jeff Hinton that maybe it's a 10 to 20% chance of annihilation. But look on the bright side, that's 80 to 90% probability of a great outcome. Um, so yeah, I can't emphasize this enough. A rigorous adherence to truth is the most important thing for AI safety. Um, and obviously empathy for humanity and life as we know it.
We haven't talked about Neuralink at all yet, but I'm curious, you're working on closing the input and output gap between humans and
Yeah.
machines. How critical is that to AGI, ASI, and once that link is made, can we not only read but also write?
The Neuralink is not necessary to solve digital superintelligence. That'll happen before Neuralink is at scale. But what Neuralink can effectively do is solve the input-output bandwidth constraints. Especially our output bandwidth is very low. The sustained output of a human over the course of a day is less than 1 bit per second. So there's 86,400 seconds in a day, and it is extremely rare for a human to output more than that number of symbols per day. So certainly for several days in a row. So you really with a Neuralink interface, you can massively increase your output bandwidth and your input bandwidth. Input being write to you have to do write operations to the brain. Um, we we have now 5 humans who have received uh, the kind of the read
Incredible.
input, where it's reading signals, and you've got people with ALS who um, really have they're tetraplegics, but they can now communicate at similar bandwidth to a human with a fully functioning body, and control their computer and phone, which is pretty cool. And then I think in the next 6 to 12 months, we'll be doing our first implants for vision, where even if somebody's completely blind, we can write directly to the visual cortex. And we've had that working in monkeys. Actually, I think one of our monkeys now has had the visual implant for 3 years. And at first it'll be relatively fairly low resolution, but long term you would have very high resolution and be able to see in multispectral wavelengths. So you could see an infrared, ultraviolet, radar. It's like a superpower situation. But like at some point, the cybernetic implants would not simply be correcting things that went wrong, but augmenting human capabilities dramatically, augmenting intelligence and senses and bandwidth dramatically, and that's going to happen at some point. But digital superintelligence will happen well before that. At least if we have a Neuralink, we'll be able to appreciate the AI better.
I guess one of the limiting reagents to all of your efforts across all of these different domains is access to the smartest possible people.
Yes.
But, sort of simultaneous to that, we have, the rocks can talk and reason, and, they're maybe 130 IQ now, and they're probably going to be super intelligent soon.
Yeah.
How do you reconcile those two things? Like, what's going to happen in, 5-10 years, and what should the people in this room do to make sure that, they're the ones who are creating instead of maybe below the API line?
Well, they call it the singularity for a reason, because we don't know what's going to happen. In the not that far future, the percentage of intelligence that is human will be quite small. At some point, the collective sum of human intelligence will be less than 1% of all intelligence. And if things get to Kardashev level 2, we're talking about human intelligence, even assuming a significant increase in human population and intelligence augmentation, like massive intelligence augmentation, where like everyone has an IQ of 1,000 type of thing. Even in that circumstance, collective human intelligence will be probably 1/billionth that of digital intelligence. Anyway, we're the biological bootloader for digital superintelligence.
I guess just to end off.
Was I? It was like, was I a good bootloader?
Where do we go? How do we go from here? I mean, all of this is pretty wild sci-fi stuff that also could be built by the people in this room. Do you have a closing thought for the smartest technical people of this generation right now? What should they be doing? What should they be working on? What should they be thinking about, tonight as they go to dinner?
Well, as I started off with, I think if you're doing something useful, that's great. If you just try to be as useful as possible to your fellow human beings, and that then you're doing something good. I keep harping on this, like, focus on super truthful AI. That's the most important thing for AI safety. Obviously, if anyone's interested in working at XAI, please let us know. We're aiming to make Grok the maximally truth-seeking AI, and I think that's a very important thing. Hopefully, we can understand the nature of the universe. That's really, I guess, what AI can hopefully tell us. Maybe AI can maybe tell us where are the aliens, and what, how did the universe really start? How will it end? What are the questions that we don't know that we should ask? And are we in a simulation? Or what level of simulation are we in?
Well, I think we're going to find out.
Am I an NPC?
Elon, thank you so much for joining us. Everyone, please give it up for Elon Musk.
Thanks,